Sounds good.
Okay, so welcome everyone. This is iTexico's webinar of the value of AI for enterprise. We have as our guest speaker, Abhay Agarwal, and please correct me if I'm wrong saying your name. So Abhay is a lecturer at the Stanford University, Hasso Platner Institute of Design, and he's also the co-creator of the course Design Machine Learning. Prior to that, he was a research fellow at Microsoft's AI Research Group, and he holds a Master in Science from the Stanford Design program, as well as a Bachelor in Science from UC Berkeley's EE&CS program. So welcome, Abhay.
Thank you. Yeah, thank you for the introduction. I'm super excited to be able to give this webinar. Is my audio okay? Is everything good? Cool. So
perfect.
Yeah, so let's get started with sort of the topic of this conversation. So I've been working in the AI field for several years now, and kind of the place that I come from in this space is that I worked as a researcher at Microsoft's AI and Research Group, a research fellow. And in my time there, I found that there was a huge lack of kind of design principles in the AI field. And what I mean by that is there was a lack of sort of intentionality in creating AI that solved users' problems and needs and was able to achieve real business value. And so what I want to do in this webinar is kind of explain what the value of AI is in an enterprise and how you can start to look at that from the lens of a human-centered design and solving business needs with creative use cases. So what does AI mean for the enterprise in general? So I think that there's a big misconception about how AI will really transform enterprises. I think people see this as a shift akin to adopting a new technology, for example, cloud. And I don't think that it could be any more different. The reason being that AI really changes how you do business at the core, down to the core fundamental of who your business is and what kind of product they sell. Oftentimes, a small AI intervention can actually change completely how you find customers, how customers find out about you, how customers learn the value of your product, how they interact with your product, how you close the deal, how you choose what to sell, etc. So these are really fundamental questions that every business needs to be asking. And oftentimes, businesses don't feel like they're in a position to be able to ask those questions because the team or the group that's adopting AI is part of a small silo within the larger business sphere and is asking those questions only from the context of their sort of chunk of what the business offers. It's also often about rewiring how information flows through your business, right? AI requires large amounts of data, which we'll go through and discuss what kinds of data that actually requires. But you have to rewire how that information flows. You have to rethink who information is reaching and how they're assessing and understanding it and what they're doing with that information and how they're acting on it. And then how you can sort of restructure that overall so that either different people are able to have visibility over the data or as AI tools edit and manipulate and curate that data, how humans are also involved in overseeing the activities of the AI. So information flow is very critical to how your AI system would work, no matter where it is or what function it does. And it often requires that businesses have to strategize and how to make that a reality. It doesn't happen overnight. The third thing that I find to be a misconception is that with AI, you often have to bring forth entirely new features for your market because the functionality of the AI is so different from what came before it. And I'll give a really great example of that after this. And then lastly, AI requires also making small technical changes that would eventually carry outsized impacts. And I think the bias within the enterprise world is that the AI must be sort of a large, sort of have a lot of gravitas as a technology, but it often just requires a few kind of key interventions that change how the business operates. And again, I'll show that next. So best example of how AI can transform enterprise and transform an entire industry is Zillow, in my opinion. So this technology has been around for a decade or more now, but the crucial innovation with Zillow was really the idea of a Zestimate. And I don't know how many of you might be familiar with Zillow, especially for those of you who are outside of the US, but Zillow is a home buying website that essentially lists every home in the US and potentially abroad. I'm not sure what markets they cover right now, but they give every home what they call a Zestimate, which is an estimated value of that house. And that estimated value is, accurate to within a pretty high fidelity range. And it's also accurate to within geographies, within neighborhoods, based on what kind of features the house has, whether the house has a big backyard or how much square footage it covers, and what kind of features are inside the house, how many bedrooms and whatnot. And so it's not a trivial feature for a website to have, right? It requires large amounts of data on house prices and house fluctuations. It needs to be accurate to several months to potentially a year at most, and beyond that, it might be stale. It requires having many different data sets be aggregated across the world into a single unified interface. And lastly, it also requires that you rethink how you interact with your customers. In the past, estimating the price of a house might have been something that required you go through a broker or an agent, and that information might actually have been fairly secret, or it might have required a high turnaround, or supposing you're doing a renovation, it's hard to re-estimate the price of that house now. So there are many different ways that sort of a housing price is involved in the process of buying and selling property. And what Zillow did was it introduced an AI feature given an estimate.
Abhay, let me just interrupt you for a little bit. Are you showing some slides?
Yes, do you not see it?
I'm not seeing them moving. So yes, I am seeing them moving.
You see that now?
Yes.
Okay, cool.
Yes,
I'm not moving very quickly.
Okay.
So right now it's a slide that just shows a screen of Zillow's Zestimate feature. So the Zestimate feature, like I mentioned, is a small AI intervention that requires a significant amount of technical work, but is not such a massive feature that might be like creating an entirely new business arm with thousands of new employees, etc. It started with kind of a smaller technical intervention, which allowed Zillow to aggregate data and combine it into a new feature. And what that new feature did was it created a new way of starting your home buying process, right? And that itself, as a feature, created a massive new market. And Zillow was able to capture a lot of mind share in the real estate process, and was able to build upon that and grow to become a larger company. So let's just kind of go through what the actual mechanics of estimating a house price might be. So let's say we have—
I'm sorry to interrupt again, but it feels like when you're presenting is just staying on the first slide that you're presenting on. So it might be better that you just leave the presentation without presenting, so that they can see what you're moving into. Yeah, I think this is fine.
Better?
Yeah,
okay.
Thank you.
That's fine, yeah. So let's talk about the mechanics of what it takes to estimate a house price. So supposing you have a database, and this database has 3 houses in it, and they have the address of the house, the state that the house is in the US, the number of bedrooms, and the number of garage spaces. So that data in of itself is fairly descriptive for a user, right? If I'm living in California and I know kind of roughly where the house is, the number of bedrooms and garage spaces, I can potentially estimate the house. So it's something that a person can potentially do. But if an algorithm were to look at all 3 of these data points, and you were to create a sort of naive algorithm to estimate the price of the house, you might look at the house in Wyoming that has 7 bedrooms and 4 garage spaces and immediately assume that this is the most expensive house. But in reality, the geographical nature of house prices means that the house in California might actually be the most expensive, or they might all be relatively the same price. So what this kind of points to is that a data-driven approach, where you have historical examples of data, housing, and how much that house costs, would actually give you sort of a potential opportunity to then derive and predict the prices of future houses and houses in those same areas. But what it also means is that your house estimation algorithm would require a lot of data. It would require having data in many different geographies, and that data needs to be labeled with accurate housing prices. And so it actually requires a fairly robust data set in order to derive this feature. And so a lot of companies and organizations and firms have data that might be at this level of quality, but may not actually be able to create this sort of specific feature and level of inference unless they actually attempt to take a closer look and improve that data. So let me talk a little bit about what the process of creating such a data set would look like, and then how it affects the business overall. So it often starts with just collecting the data. So data collection is, can require either lots of money or can require having access to certain proprietary information, but every business will have to collect it. Then there's also a data cleaning and reviewing and augmentation and joining process where data is mixed with other data points and their columns and rows are joined. The data is cleaned, so you take out things like null values and erroneous entries or biased entries or stale entries. And then you augment that data potentially by adding extra columns. For example, you can add what kind of soil is in this particular area, if that's a way of easily helping you estimate how much it costs to do renovation. And so you create this sort of full-featured database with all this information and all these house prices, and maybe a subsection of them, 10%, are labeled with the house price, but then the rest aren't. So the task of the data scientist is to go in and create an algorithm that's able to fill out the rest of the 90% of those house rows with their price. So that requires a data infrastructure and algorithm design, where your engineers and researchers can actually sort of experiment with different data science algorithms, finding what is the best fit for the data set, for the level of entropy or noise that exists within the data set, and what are the boundaries of, within what range does your algorithm need to be correct, or in what percentage of cases do you want to overestimate or underestimate the price. So it can become a decently complex procedure, but it requires sort of this step in order to achieve the kind of business value. And then finally, after that, kind of an underappreciated element of this sort of integration of AI is the UI and UX design and the actual business restructuring that would have to go on top of all of this technology. So once you have the technology, once you have a database that can estimate housing prices, you need to present it to people, and you need to present it to your stakeholders and your business, and you need to operate that system very proficiently and well. And so that's kind of what I would consider the pipeline of developing AI technology for your enterprise. And as you can see, it's a long process and it requires many steps, but it's something that is not kind of it's not the same as how someone would describe AI to you, who doesn't have experience in this space. Someone might tell you that AI is a feature set or something that you can add to your product by looking through a vendor. And for the most part, it requires actually looking at your core fundamentals of your business and then reshaping those in order to really achieve that business value. So let's think about what data would really look like and how you would actually achieve good quality data. I've got a chat question. I get questions from the audience that are asking if the slides are being advanced. So I'm potentially...
I think you're on number 5 right now.
Oh, so the video is going slower than my audio? Is that how is that what you think is happening?
I don't know if it is, but you're moving your mouse and you're on slide number 5.
Really? Because I'm on slide number 7 on my machine. Let me just try again.
That's interesting. If you want, I can share my screen and see if that works.
Yeah. Let's try one more time and then. Sorry about the technical difficulties. Okay, do you see slide 7 now?
Okay, hold on. Yes, we're on slide 7 now.
Okay, if that happens again, then I'll ask you to present and then I'll just ask you to move the slides forward. Totally apologize.
Yeah, that's perfect. Thank you. And thank you, Tom, for, I was also thinking that it was supposed to be on slide 5, but it seems like now.
Okay, Yeah. Well, anyways, on slide 7, you can see that there's a list of data points, and really what I want to provide is kind of an explanation of what it takes to create a high quality data set. So it requires 5 main things applied to your data. Your data needs to have breadth. So it needs to have a lot of rows or examples of the data. So for example, in a housing data set, a lot of different addresses. Depth means how many columns. So how much information do you have about each house? Freshness is how recent is the data. Quality is how accurate the data is. So how did you collect that data, and how did you achieve the house prices for the data that's labeled? And then the cost is how expensive was it to collect that data. And so these are all axes upon which you as a business need to use to understand how do we collect the best data that is going to help us achieve the most accurate sort of data science inference. And if we're not able to achieve one thing, for example, if we don't have the freshest data, how do we account for it by the other 4 categories? So every business is going to have to struggle to achieve the best data and to have that data become their moat in the industry that they're in. And so just think very hard about how that can be achieved in whatever business vertical you're operating in. So in this case, on slide 8, you can see that there's 3 data points, and then each of them have multiple different kinds of piece of information about them. So there's a lot of depth to this data. So it has price, square foot, it has whether it has a patio, the number of bathrooms, the kitchen square footage. One thing you can do just as a quick exercise, if you're trying to understand what use cases you can obtain from AI, is you can imagine that one of these columns has been removed. And imagine that the world at large, that your users kind of have this data implicitly with one column removed. So if you think about the Zestimate in Zillow, it's kind of like they have all the elements of the row except for the price, right? And Zillow's key value as a company is to estimate the price for the house. But you can also imagine that other companies, for example, might have other use cases where they might be able to achieve different data, might be able to achieve different ends through that data. So for example, maybe you're a kitchen remodeling company and you have all the data except for the square footage of the kitchen. And so you as a business can create an algorithm that infers the size of the kitchen. Cool, thank you. You as a business can infer the size of the kitchen given that other data. And that allows you to have sort of a special advantage in, for example, remodeling kitchen and finding customers that might have a certain size of kitchen for your business value. So this is kind of an interesting exercise you can do. And so you as a company would take your data set that you have that doesn't have this existing column, such as a kitchen square foot, and you would collect that data manually for a certain subsection of your rows. So for a certain subsection of your houses, you would collect that and then use that, what is called training data, to infer the square footage for all the rest of the data points in your data set. And so that's kind of an interesting exercise that I would encourage anyone to go through if they're interested or curious about what creative use cases they might be able to find from their data. So go on to the next slide, please. So in structured data, which is the kind of data that I've been talking about with rows and columns, you have 3 main kinds of machine learning that can happen through that data. You can conduct inference, which means what I said before, which is given data in additional columns, estimate the value of a data in an unlabeled column. Then you have prediction, which is given data that's in a time series, estimate the value over time, given a time frame. And then there's classification, is given a list of labels, classify data points into one or more of those labels. So these are all different use cases that you can think about when trying to identify a use case of your proprietary business information. Next slide. And then the other kind of data that's becoming more prevalent is unstructured data. So this is data that is not within a row or column database. This is data that exists in file formats or unstructured formats and doesn't necessarily have a lot of metadata. And so the task for machine learning on this unstructured data is to extract meaningful metadata from this unstructured information. For example, natural language processing requires that you derive the meaning or text out of speech data. Image video processing is identifying labels and objects in an image or a video. And knowledge graphs is identifying relationships between entities within that graph and using those relationships to identify, for example, information about a particular entity based on what you know about other entities. Go ahead. So putting it all together and how this would affect your business, think about an example of a call center to really look at how all these different kind of interventions via AI can really change how you do business entirely. So in a customer support 1.0 scenario where you have a call center which is not intelligent, it's not augmented with different capabilities, is a call would come in. Can you actually, sorry, go ahead. That's my screen. A call comes in. No, please go back to it. So a call would come in. You might have a switchboard or some other router assigning the call to an open agent. And then the agent would try to attempt to solve the query of the customer. These random calls would come in and the agent might not necessarily have context every time. So there might be sort of a flailing or a questioning or going to a manager, and then the call would end. And the call would end with a resolution of some kind. Maybe the customer is angry or they're happy or satisfied and you don't collect that data, so you don't know. So go to the next slide, please. So in a customer support 2.0 scenario, maybe the query starts through NLP. So a customer's query comes in and an NLP software system would assess the meaning of the statement and route that to a relevant specialized agent. And then that agent might then be able to solve that query better because they have a searchable dashboard with the most likely answers to that question. And then after the call is done, the call is automatically assessed for the usefulness and success of the call. And then lastly, the successful support strategies and agents are then promoted so that more and more specialization can occur and more queries can be successfully addressed by an agent. So what you can see here is that even though this customer support 2.0 pipeline is comprised of several different interventions that may each individually not necessarily affect the overall outcome, put together in a feedback cycle, they all create sort of an entirely different way of doing business that is fundamentally more successful than what came before it. Go to the next slide, please. However, there's sort of a trade-off between how you do your business and the kind of data that you use. So the data, the quantity of data that you want to be able to process, for example, a small amount of data would be tens or hundreds of rows, whereas a large amount of data might be millions of rows, creates a higher complexity of inference. So the more data you have, the more kind of nuances that data has, and therefore the more complex your model has to be in order to process that data. And I think there's a big misconception here that a small amount of data, like a couple hundred or thousands of rows, is not enough to do anything intelligent. And the reality is that as long as you're able to sort of completely describe the space that you're predicting, and what I mean by that is you don't have any data points that don't exist within your data set that would be necessary in order to estimate something. So if you have house prices, if you have house prices within every neighborhood or with every kind of number of bedrooms and bathrooms, you don't necessarily need a larger and larger quantity of data as long as you represent the input space. And so that's what is required. But the more data you have beyond that, the more complexity of inference you have to deal with as an organization. Next slide, please. And then the more complex your data is, so the more unstructured it is. So for example, going from very non-complex data as rows and columns to extremely complex data comprised of voice, audio, files, etc., the more complex your model gets. So while there is sort of a value in being able to understand unstructured data, you also have to recognize that you're going to be instituting much more complex models that have many more failure scenarios. And therefore, you want to sort of use that as, leverage the value that you can get with the lowest kind of complexity data you can find. And so if you have data that's already labeled with metadata itself, it would actually be much more valuable to do a simple model using that data than to take the original unstructured data and have a slightly more accurate, though incredibly more complicated model. Great. So I know that was a lot of technical discussion. I did want to pause there if there are any questions in QA from the audience. Otherwise, what I wanted to do next was look at a variety of use cases that might be able to pique your imagination for how your enterprise might work in a world of sort of pervasive machine intelligence. So beyond kind of the initial use cases of data and how they get leveraged in your organization, what are some of the creative ways that that data has actually been used in the recent past by companies who have special information? So maybe I'll go ahead. So the first sort of big use case is around conversational commerce. So this is an area that's been sort of really attacked over the last several years with technologies such as bots. And conversational commerce is really the idea that customers want a more immediate, real-time kind of commerce experience where they can text and use natural language in order to request and order something. So the sort of prototype example that got big was 1-800-Flowers, which is a traditional flower delivery service, but they instituted a conversational system that allows you to order flowers, and it takes you through a process of asking you what kind of colors and what kind of varieties of flowers that you want, and then allows you to order that on the spot. And so this is sort of a use case that garnered a lot of excitement, and some of the advancements of natural language processing seemed like they were putting us on the cusp of having a conversational commerce based world where pretty much every industry would be based on this. However, at this point, the market is actually highly saturated, and it's really hard to get a user's attention, simply because there's so many other vendors or providers that are giving this kind of conversational experience. And yet the return on investment is actually fairly low, because a pretty low percentage of users actually get exactly what they want in the way that they wanted to have it. The reason being that this is a sort of a new way of doing business and of ordering things and of interacting with sort of the support of the company. And therefore, it's not something that every user is going to be immediately attuned to. And that what that means is that there's maybe specific success cases, but lots and lots of failure cases where a company tried to use conversational commerce, but was essentially unable to crack that sort of use case with their customers who are not used to ordering that in that way. So it's an interesting area, but something to be sort of hesitant about if you think that this is going to open up an entirely new market for your company. Next slide, please. So the next section is about computer vision and object labeling, which is, there's a lot of excitement about this due to deep learning making advances in the market, where you take an image or video and you're able to automatically infer object labels in that video. So you can identify a bounding box and a label for something. And this can actually be customized to your proprietary data. So you can have your own video footage, and you can hire a team to label that footage, and then you can get started with conducting inference on unlabeled video and image data. So that's in of itself a trade-off, that it requires sort of an expensive labeling process for any company that's trying to institute a proprietary solution here. There's many different ways of deriving value from this. However, the technology is very fickle. So the failure cases are often very, very obvious, and therefore it can be hard to use this in a high risk situation, even if there's a high payoff. So for example, in the security space, in which you're trying to detect intruders or trying to detect a thief coming to your house, etc., the video analysis might seem good at first, where you're able to assess the video frames and find which frames show that there might be an intruder. However, in reality, the number of false positives is so high that it might actually be more trouble than it's worth. And again, like, there might be a world where this becomes pervasive and it becomes so accurate that it's much more accurate than any human. However, that requires mountains and mountains of labeling data that's highly expensive and has to be refreshed all the time, and is based on small minor details like what kind of camera you're using. So it's useful in a low risk scenario, but in a business critical scenario, this seems very, very challenging to institute successfully. So where this has shown the most success is marketing and advertising, where you're labeling a logo, or you're labeling an object, or potentially you're labeling whether a customer is smiling, or trying to assess in mass, images on Instagram or something, where you're really looking for a rough correlation or a rough data point, and you're not actually trying to make a business critical decision with every inference. Next, please. Another area that's gained a lot of interest is Alexa skills. So Alexa skills are where you use a voice activated device like an Alexa or Google Home or Siri, and you ask it to do something. And the skill element is that you have certain code words that Alexa is trained to know goes to your special software. So you can sort of install, so to speak, these skills into your Alexa device. And this has gained a lot of attention, primarily because it's a consumer use case. And therefore, it's become widespread in society, and people talk about it, and it's fairly well known. Interestingly enough about Alexa skills is that there's a really low complexity in designing your own Alexa skills. There's almost no AI involved at all. All the AI is done on the edge with the device itself, where the device is inferring natural language and turning it into text. There's a tiny amount of complexity where that text, for example, these utterances that someone says in order to turn on your skill, can be in a variety of different formats. So you might be able to ask, Alexa, help turn on my TV, or you might say, Alexa, turn on the tube. And the fact that those are different ways of saying the same thing would have to be understood by your system. So it's fairly low complexity and therefore fairly easy to implement. However, similar to the conversational commerce, there's actually pretty low user engagement, almost non-existent user engagement for the vast majority of Alexa skills for non-home related tasks. So for home automation, Alexa skills often do get used simply because the Alexa's in the home and there's kind of a cognitive harmony there. There are also some Alexa skills that are sort of used in the entertainment world, for example, activities or games or puzzles for children. So what that means is that the Alexa skills have sort of a decent PR value, but you're really not going to be able to attain an entirely new use case the way that a Zillow or a Zestimate was able to find. Okay, next. So next is entity linking. So this is something that actually has been around for much longer than most of the other kind of deep learning AI use cases. So entity linking basically means you have a large graph, and that graph is essentially entities. So it could be people, and then the edges in your graph are like linkages between people. So this person is friends with this other person. So has been a lot of use cases for this technology in the security space, where you need to create a massive graph of all, for example, suspects in a case, and then you want to do some graph analysis to say what is the sort of connectedness of different entities, and try to find, if you have one person who's a suspect, who are they likely to have communicated with and contacted with, etc. But this is actually a fairly widespread use case that can be used in many different spaces, for example, in genomics or in medicine, where you can link entities, which medicines address which diseases, and then create interesting correlations and inferences based on what you know to, for example, identify an unknown correlation between a given medicine and a disease. However, the challenge with entity linking is that it requires a very complex UI UX design, because that information is so locked up in this complexity of the graph, and just surfacing sort of the mathematical results is not enough. It requires that you actually communicate those results in a way that's understandable to your users. And that's challenging, and something that would require sort of more effort than often most enterprises can deploy on the fly. However, for entity linking, there are some very specific, very highly valuable applications of this technology, especially in the security and surveillance space. And so there's a handful of companies that have created billion-dollar valuations just from addressing this particular technology on its own. So that it's somewhat promising for that reason, but it really requires you have a special use case in mind with your business. Next one. So another area that many companies have tried to find in a use case for in recent years is sentiment analysis. So this is where you collect a data set of, for example, phrases or images, and then you label a part of them with a sentiment, for example, an emotion, happiness, sadness, etc. And so with that, with those different sentiments, you can then label unknown data, for example, unknown phrases or images, and understand particularly an emotion behind them, and potentially use that in some kind of business valuable way, where you look at customer reviews, you look at customer comments, and you do a sentiment analysis on them to derive sort of an understanding of what are emotions that this product creates, etc. So it has an interesting sort of origin to the fact that this is now available in a sort of a small way. However, there's lots of hidden complexity in this technology, given that emotions are not easily labeled at the outset, and kind of requires a lot of training on the part of your labelers. And so collecting this data is actually very challenging. And the moment you go from one domain to another domain, for example, product reviews to comments on YouTube, it completely changes what kind of inference you can create, because the style of conversation, the words used, the emotions conveyed are actually fairly different in those different domains. And we have yet to find a very comprehensive, accurate sentiment analysis system, if that's even possible to create, given that people can often disagree about emotions just in conversation with each other. The accuracy is drastically reduced with the number of classifications. So with the number of sentiments that you want to label, the accuracy is drastically reduced to the point where if you have more than 8 or so emotions, you often get something that's close to random. With 2 emotions, for example, happiness or sadness or positive and negative valences, you can often get away with it because there's a very high correlation between the kinds of words used when you're happy or sad. However, when it comes to frustrated versus confused versus inquisitive, right, when you get to the complexity of these labels, it's often really challenging to understand and then to derive real meaning out of that. It also often creates really strong biases based on whoever's doing the labeling. So if my interpretation of sadness or frustration is different from yours, then my interpretation actually gets leveraged and used as part of the business, whereas yours might just never become part of the system. And so that's really challenging, because if you see kind of day in and day out at the front line using the system that it's getting the sentiments wrong. For example, if you're doing a sales pipeline where you're doing sentiment analysis of inbound interest, and you as a salesperson know that these customers are actually interested, but the sentiment analysis is labeling them as frustrated, then that can be very annoying and challenging. So those biases can be very hard to eliminate. So what this means for this use case is that it's almost never leveraged in a mission critical way. So it's never in the critical path. It's often an augmentation or potentially a performance review assistance tool, but it rarely is used as a business value case. So then next we have predictive operations. So this is an area that's gained a lot of traction in the last 5 years, particularly because it's made a lot of progress in a variety of different kind of traditional verticals. So we're talking about manufacturing, logistics, et cetera, shipping, where these operations, every percentage point of optimization is tens or hundreds of millions of dollars of value for the company. So there's lots of value to add in creating predictive operations, where you take existing data of how your business runs and you turn that into a prediction about the success or a pattern within future operations. And this has sort of been captured by many different vendors and many different AI providers that have sort of like drop-in AI systems to do a lot of statistical modeling and analysis. However, if you really want to leverage the value of predictive analytics, you have to think about reorganizing how you do business. So restructuring your organization is absolutely key in order to derive value from this kind of predictive operation, right? The last thing you want is for your company to continue doing things the traditional way, to not use the data, to not leverage the insight, and still use human-to-human intuition in order to do business, even though you're paying for this expensive data system. So you really need to think about how you take a predictive operation and connect it to other operations within the business so that people can be the champions of this technology. However, there's lots of different use cases. You just need internal adoption in order to see the value here. And so often this requires having sort of a high level chief executive or someone at the company that's really willing to sort of get their hands dirty and change how the business works and take sort of a short-term hit for a long-term payoff. Great, next one. So then there's a whole category of sort of user-facing AI. So the Zestimate, scoring tools, etc. And these are really interesting because this can really change and transform how the business works. Just providing a new kind of information that previously took a user, 2 weeks for a turnaround for a human analyst to come in and give you that information, to have that be real time, can really transform what the business is capable of doing. For example, in the insurance space, to be able to estimate the price of an insurance claim automatically, just so that a user can have a rough idea, can often transform whether a user has a positive interpretation of your insurance business or a negative interpretation. So these user-facing AIs can be extremely valuable. It can also differentiate you in the market. It can also bring users to your website or to your app. So it can really transform things. It can help you understand your users better, help you collect more data about user interaction. So there's really a lot of value here in creating AI that faces the user and provides some estimate or score or number or just new way of interacting with sort of the job at hand. However, it does require careful adoption. The reason for that being that you can often turn a user away if the accuracy or noise within your system is suspect. It can often turn users away if the business is ignoring the nuance of the user's claim or interest by using this AI tool that sort of glazes over any of the intricacy. So it requires you to carefully look at the pipeline of how information flows through your business, to look at from the perspective of the user. When they reach your portal, what's on their mind? What are they thinking? What do they want? What's the terminology that they're using, and how are you marketing to them? And then how do they use this AI tool, and under what context? So are they using this as a business value case? Is it more of a gimmick? Is it more to help them understand your business more, or are they actually achieving some outcome? And then you have to look at the internal operations of how you're collecting the data to make that inference available to the user, and making sure that you're serving all the different niche use cases in that community. And what that also means is careful UI UX design. It means creating an interface and an interaction that's really beneficial to a user so that they achieve kind of more value and more interest and more adoption of your tool. Because any bad UI or UX design can turn people away by confusing them or making it seem that the AI is too complicated. Cool, moving on. And then lastly, kind of a broad area that's transforming every industry from my vantage point is this notion that I've called augmented workforce. So what this means is that people who do their job inside of a company, whether those people are recruiters, whether they're salespeople, whether they're analysts, whether they're managers, have a use case for AI for themselves. A recruiter might be able to use AI technology in order to filter job applications better. A salesperson might be able to use AI to filter through sales leads better. So there's many use cases where a skilled professional can actually achieve their job better and reduce the amount of rote labor that it takes for them to achieve their sort of performance using a dashboard or a tool or an interface. And so the way I think about this is that a lot of jobs that have been previously kind of intuition-based, person-to-person based, where a recruiter sits in front of many people or reads through resumes, are going to, in the future, go through a portal or an interface. So the recruiter will be reading resumes through an interface where they're looking at them digitally, where they're looking at highlighted portions where individual pieces are shown to them so that they can assess it faster, or they're re-ranked so that the resumes, the most interesting ones, appear at the top, or they're augmented with other information about that person, for example, from other portals. And so this kind of metaphor for augmented workforce is really being pervasively applied to every industry, especially skilled industries. And so if you think about how your business is done at its core, and what value you provide, what value your employees provide to the company, and maximizing their productivity in the organization, you should think about augmenting those employees with more information and more predictive inferential information that can be obtained via business value data that you have inside your company. So it's often the case that you can go through a sort of a successful product vendor that's in this vertical. So for example, there's recruiting technology companies that all they do is provide an AI-based tool to assist in recruiting. But this is also a use case where your company can internally develop new IP around augmenting and skilling your own workforce so that you do what you do best, even better than the competition. But what this requires is that you train the workforce again, and that you skill them in a kind of a new way of working. However, in the long run, it can create huge cost savings, but it'll require at least a year to see that cost saving really achieved when new training, new regimens, new performance reviews, new ways of working together, new ways of evaluating are instituted across the company. So great. So just wanted to wrap this up by saying that we're at the AI Innovation Center in iTexico. It's a new organization, a new center of excellence, as we're calling it, that has a variety of uses and sort of can help you in a variety of ways, essentially. So we're starting out with 4 kind of key areas that we want to help companies with. There's design sprints, which can help you understand what is a business need that you want to achieve and kind of take you through a design thinking process in the same way that we've gone through some of these ideas already. Then we have a data management arm that really helps you achieve more, leveraging your data better and faster and more accurate. There's process automation, which allows you to solve rote tasks more easily and quickly. And then there's a machine learning arm that allows you to really create new value from your data, from your existing data, and find some of these exciting use cases for transforming your organization. So that's it for the webinar. If there are any questions or comments, I'm happy to take them now. Otherwise, thank you for your attention.
Yes, so we're more than happy to answer any questions you have. And we will be here for a couple of more minutes. I have a question for you, Abhay.
Sure.
Is there an example that you can give us of something that is very focused on enterprise that has implemented AI that you think is very successful?
Yeah, totally. So I think in the predictive operations space, there are a lot of success stories. I think the reason why we don't necessarily hear about those success stories is that the AI used there has sort of become normalized or assumed. So for example, in supply chain logistics, estimating and predicting when a parcel will arrive at the destination is sort of a key business use case that has been adopted across the industry, or is in the process of being adopted. And there's many vendors that specifically try to address that particular use case. So I think within different verticals, within different industries, there are really highly valuable use cases there. And oftentimes you can't see it sort of from the outset, given that everyone else in your industry is doing something manually. So I think, for example, in a shipping company, even though it's highly automated, there's still shipping companies which use paper documents for freight forwarding. And so there's a company that used kind of a human-based system that includes an AI system where it takes those paper forms and immediately ingests the data by automatically recognizing handwriting and having a human go in afterward and correct any mistakes in the AI system, and then immediately digitizes that form so that those shipping and logistics companies can then do their work better. So it's a small intervention, right, that doesn't require the necessarily large sort of overhauling of a technical system. However, that small intervention created a massive outsized impacts in the organization as a whole, because now those non-technical kind of logistics and freight forwarding companies are able to join the digital revolution in their space.
And I think that's what's important about AI, right? Like the implementation doesn't have to be huge in your company. It can be a small change, but that can create a lot of impact.
Sure. Yeah, exactly. And I think that the main challenge in developing an AI service or an AI-based product is in sort of the way that you have to reshape your organization and rethink some of the sort of new realities of living in an AI world where information is flowing differently from person to person. And therefore, your internal tools and metrics and dashboards might need to be overhauled in order to really achieve that business value.
Wow. Okay. Well, thank you so much, Abhay, for your time and for your insight on this space, for sharing with us the value of AI for enterprise. And this recording will be available as well. So I will be sharing that with our attendees and with our other customers. So thank you so much for your time and hope to speak to you soon.
All right. Thank you so much, everybody. Take care.
Take care, everyone.